हेलो।
Yes, sir.
హలో వినిపిస్తుందా?
Yes, sir.
వినిపిస్తుందా మీకు? హలో.
Yes, sir. వినిపిస్తుంది సార్.
యూనిట్ 7 మ్యూట్ లో పెట్టండి.
ఓకే సార్.
వాయిస్ క్లియర్ గా లేదు. డిస్టర్బెన్స్ వస్తుంది చూడండి. హలో, యూనిట్ 7. యూనిట్ 7. ఆర్ యూ ఆడిబుల్? ప్రైమర్ అండ్ డ్యూయల్ ఎల్పిపి. ఓకే, యూనిట్ 7. యూనిట్ 7, ప్రైమల్ అండ్ డ్యూయల్ ఎల్పిపిస్. ప్రైమల్ అండ్ డ్యూయల్ ఎల్పిపిస్. ప్రైమల్ అండ్ డ్యూయల్ ఎల్పిపిస్. Concepts. Concepts. Introduction. So original LPP. The original LPP, which is given is called, which is given is called. Screen కనబడుతుందండి? Hello?
Yes, sir. Yes, sir.
Okay. Is called primal. It's primal. Every LPP which is given is called every LPP which is called primal. Primal means first one. Then that meaning. The original LPP, the original LPP is called primal. But the same LPP can be described. The same LPP described, solved by taking the same LPP, but the same LPP solved or transposed the conditions or solved or transposed the conditions is called dual. Duals. For example, less than or equal to is there. We'll use in dual greater than or equal to. Here, greater than or equal to is there. We'll use in this is primal, this is dual. Greater, less than or equal to. That's it. Next. Formation of dual and LPP. Formation of dual. Formation of dual in LPP means linear programming problem. That means that the given LPP is primal. Let the given LPP is primal. Given LPP is primal. Is in the form maximize ZX equal to C1x1 plus C2x2 plus so on dot Cn xn. So subject to STC. STC means subject to constraints. subject to constants. Subject to constants. What are that? A11, A11 x1 plus A12 x2 plus A13 x3 plus so on plus an comma xn an xn a11 comma xn less than or equal to b1. Next, similarly a21 x1 plus a22 x2 plus so on plus so a2n xn less than or equal to b2. So dot so on. That means amn am1 x1 plus am2 x2 plus so on dot amn xn less than or equal to bn where x1 comma x2 comma etc xn is greater than or equal to 0. So it can be represented in a matrix formation. This whole, consider this is equation number 1. That one can be represented by matrix form. Matrix form. So maximize Z's maximize Z equal to Cx subject to constant subject ax is less than or equal to b and x is greater than or equal to 0, greater than or equal to 0. Therefore b transpose belongs to R of m. R is a real number. So A can be written as matrix form we are writing. A equal to A11, A11, A12, so on A1n. Next, A21, A21, A22, etc. A2n, so on dot AM1, AM2, so on AMN. Therefore, capital X equal to x1, comma x2, etc. xn, or b equal to b1, comma b2, so on bn. So what we did, subject to constant, first primal to we converted in a matrix form. Next. Next. Important points in formatting the dual form of primal problem. So important points. So nothing but algorithm. Algorithm means step by step procedure. So first one, in primal problem. In primal problem. If there are n variables, n variables and m constants and m constants, m variables and m constants, then it is dual problem. Then it is dual problem. Then it is dual problem. M variables, n constants. Opposite. Variables becomes constants, constants becomes variables. M variables and n constants. N constants. If the primal problem has the primal problem has less than or equal to less than or equal to, we have to convert. We need to convert greater than or equal to. Convert greater than or equal to. Vice versa. Vice versa means as it is, etc. Continuation. If a problem is greater than or equal to, we need to convert into less than or equal to. Less than or equal to greater than or equal to. If the primal problem has its objective function, primal problem, its objective function or cost function or profit function, same. Objective function, objective function as maximize function, as maximize maximize function. We need to convert minimize function, convert or transpose minimize, minimize, minimize function. Fourth one, the cost function, cost of objective function in primal problem, the cost of the objective function, cost of the cost of the objective function, OF means objective function, in primal problem will become, in primal problem will become as constants, as constants, as constants, as constants. And the constants of the primal problem constants of the primal problem. Primal problem will become the cost of the objective, will become the cost of objective. OF means objective function in dual problem. Dual problem. The decision variables in both the decision variables. DV means decision variables in both primal and dual. In both primal and dual. Non-negative. Non-negative means positive. Positive numbers. Positive numbers. Next, from equation number 1, from 1, we converted before, from 1 means equation number 1. That is primal. We are converting into dual. The dual of the above primal problem. Dual of the above primal problem. There is max z. Here minimize z. Minimize zy. There is a zx is there, here zy. Minimize zy. That equal to b1 y1 plus b2 y2 plus so on bn y1 yn. What is y1 here? y1 comma y2 comma etc. yn are duals. They are duals. So a subject to constants. A11 y1 plus a1 a21 y2 plus so on am1 y1 is greater than or equal to c1. Similarly, a12 y1 plus a22 y2 plus so on plus am2 y2 is greater than or equal to c2. Similarly, so on a1n y1 plus a1 no, a2n y2 plus so on amn ym greater than or equal to cn. And here y of I is greater than or equal to 0, where I equal to 1, 2, 3, so on here. Primal dual. Here, primal problem. primal problem, dual problem. In primal, max z, that equal to sigma j equal to 1 to n cj. హలో హలో సిజే చెప్పండి. ये मैं क्लास में हूँ, बाद में करता. सीजे क्रॉस आई जे in dual minimum z min z means minimum z y z y or z w as you wish, anyone you can put. Sigma j equal to 1 to n bi by I bi by I. So yes, it means such that in primal j equal to 1 to n j equal to 1 to n aij xj aij xj xj is less than or equal to bi, where I equal to 1 to m equal to 1 to m. Here sigma j equal to 1 to n equal to 1 to n. Aij by j aij by j. Here j equal to 1 to n same. J equal to 1 to n. Yi is greater than or equal to 0. Yi is greater than or equal to 0. Next. So on theorem we'll discuss. Theorem a 10 marks question. Theory. What is that theorem? The dual of a primal problem is a primal theorem statement. The dual of the dual dual of the dual of a primal problem is primal problem is the primal theorem for most important for 10 marks question. Proof. Page number 95, you'll check it. Consider the primal problem. The canonical form of minimum z. Dual form also known as canonical. The canonical form. The canonical form means also known as, that is a dual form. Dual form also known as canonical form. So minimum zx equal to minimum zx equal to cx. Cx. Subject to constant, STC. STC means subject to constants. Ax is greater than or equal to B. Ax equal to greater than or equal to B. Ax is greater than or equal to B. X is greater than or equal to 0. Means positive, that means. Where A is a M cross N quotient matrix. Where capital A is a M cross N. M cross N quotient matrix. Quotient matrix. Quotient matrix. B transpose B transpose belongs to power M theta. Cx transpose Cx transpose belongs to epsilon power M. This is belongs to symbol epsilon. On applying the rules of the dual problem, we can apply the rules of dual problem. Means algorithm, step by step procedure. Dual problem. Max zy equal to max zy equal to B transpose y. Subject to constants. A transpose y less than or equal to C transpose, where y is greater than or equal to 0. That means primal is the standard form. Let us express, convert primal into SF means standard form. SF means standard form. मैं क्लास में हूँ, बाद में बात करूँ 2:30 के बाद standard form. Z of y, zy star equal to minus z of y. That means what? How do you wrote z of y star? Z star y is nothing but minus b transpose y. That implies minus a transpose y is greater than or equal to minus c transpose y is greater than or equal to 0. Y is greater than or equal to 0 means positive. So dual of the above expression is dual of above expression. Maximize means max z star that equal to minus C whole transpose whole transpose whole transpose X that equal to minus C X. That implies subject to minus A transpose whole transpose X less than or equal to minus B transpose whole transpose. That implies AX is greater than or equal to B, which is primal, which is primal. Hence proved. This theorem for 10 marks. Important. Next, fundamental theorem of complementary slackness theorem. This proof is higher classes, but statement we will discuss. Yeah, complementary slackness theorem. Slackness theorem. Complementary slackness theorem. If X star and Y star are the feasible solutions, if X star and Y star are the feasible solution, to the primal and the dual problem. To the primal and dual problem. Dual problem. Primal and dual problems respectively. Then the necessary and sufficient condition. Necessary and sufficient conditions. Necessary and sufficient condition of X star Y star to be the optimal solution for X star and Y star to be the optimal solution to the respective problem, to the respective problem, respective problems. So yi x n plus I equal to 1 to m and x j y m plus j equal to 0, where j equal to 1 to m, 1 to m, 1 to m, where xi plus 1 ith slack variable in primal LK. This one x n plus 1 is the ith slack variable, is the ith slack variable. Variable in LPP, primal LPP. Surplus variable here ym plus j. Ym plus j is the jth surplus variable in dual LPP. Okay. This proof is not given here. Further class we will discuss. So using this duality and simplex, based upon this concept, one problem we'll discuss. The problem 7.4.2. 7.4.2. Example problem. Write the dual of the primer. Write the easy problem, 5 marks question. This is write the dual of the primer. Maximize z equal to maximize z equal to 4x1 plus 2x2. 2x2. Subject to constraints. STC means subject to constraints. Keep in mind. Minus x1 minus x2 less than or equal to minus 3. Next, minus x2, they got it. That printing mistake, you have to write down minus x1 plus x2 greater than or equal to minus 2. And x1 and x2 are greater than or equal to 0. x1 comma x2 greater than or equal to 0 means positive. Solution. First, given problem, primal problem, you have to write in standard form. The standard form of given LPP. Write in standard form. Write in standard form. Write in standard. Standard form is what is given first. Max z. Max z. That equal to what is there? 4x1 plus 2x2. 2x2. Next. Minus x1 minus x2 is less than or equal to minus 3. Next, here greater than or is there, you need to write greater than or equal to less than or equal to. Multiply by minus both sides of the equation. That becomes x1 minus x2 is less than or equal to 4. Less than or equal to 2. Where x1 comma x2 greater than or equal to 3. So first, by our concept, we need to transpose. Transpose matrix A, suppose A equal to, what is the matrix is there? Minus 1, minus 1, 1, minus 1. That implies A transpose. A transpose means rows becomes columns, columns becomes rows. I will write columns into rows. Minus 1, 1, minus 1, minus 1. Right? Into. You consider W1, W2, or Y1, Y2 as you wish. So Y1, comma, Y2. That equal to. What you need to write? First, this quotients. that equal to 4 comma 2 transpose. That becomes row, becomes column 4 2. That means minus y1, minus 1 into y1 minus 1 into y1 minus y1 plus y2, that equal to 4. Next, minus y1 minus y2. So here that becomes that here what is there? Less than is there. You need to write greater than symbol. Greater than or equal to 2. Next, here max z is there. Convert into min z. Minimize z. Minimize z equal to minus of here minimum z. Minus here 3 2 is there now. Minus 3 y1 constants plus 2 y2 2y. So what we did here, most important 5 marks and easy also. Here what the given problem, given problem we wrote in standard form. Maximum z equal to 4x1 plus 2x2. So minus x1 minus x2 less than or equal to minus 3. So x1 minus x2 less than or equal to 2. x1 x2. What we did, that A matrix. Matrix means the constants, quotients. X1 quotient is minus 1. X2 quotient is minus 1. Here x1 quotient is 1. X2 quotient is minus 1. This transpose we did. Transpose means rows into columns or columns into. I did columns into rows. So here y1, y2. What are the y1, y2? Are the dual variables. Let y1 comma y2 or w1 comma w2 as you wish, are dual variables. Dual variables. So multiply r1 c1 r1 c2 like that. This C transpose in the theorem we wrote now, A transpose of x equal to or less than or equal to or greater than depend upon. Here less than is there now, greater than we need to write greater than or equal to C transpose. In theorem we discussed just now. That theorem is 10 marks. This problem is 5 marks. Any problem is given. No? So y1, y2 are dual variables. This is C transpose. This consider C transpose. This is A transpose. Right? Here variables. These are the X or Y variables. So what we wrote? Minus y1 plus y2 greater than or equal to 4. Minus x1 minus y1 minus y1 minus y2 greater than or equal to 2. Here max z is there. I need to write convert minimum z of constants by the algorithm of duality. Algorithm of duality. Understood? Any doubt? 5 marks compulsory question. One theorem in this chapter. One theorem on conditions. Understood? Anybody, any doubt? Anybody having doubt? Please respond me. Okay. This chapter is over. So tomorrow we'll have a unit 8. Relationship between primal and LPP. Have you got it? Anybody any doubt? Okay. Here in this unit, we discussed one theorem and one problem. Theorem for 10 marks, problem for 5 marks. Most important. Okay. Thank you. I'm leaving.